Hello everyone, this is the fourth tutorial series about creating a game engine from scratch. Here is Gilberto Ribeiro, and I wanted to contribute the explanation about shaders. It will be fast as possible. Specifically about shaders. Shaders are built to run in multiple threads that the GPU customly run. If you had a GPU, it has maybe thousands of processors, and because we can work on specifically each individual pixel of the screen, because we are drawing it on the specific resolution that we want. We have a multi-massive parallel processing, and we need a very specific problem to treat that. And here we have shaders. And shader, we have two mandatory shaders that we need. We need the vertex shader and the fragment shader. The vertex shader will be processing for each vertex that we are using. In our example, we have 3 vertices, and then the GPU will going to run this program, vertex shader, for each individual vertex, described as in here. And the fragment shader, our program going to run for each individual fragment of the surface that we are drawing. And because this is going to happen once for every model, we need to emphasize that this run for each fragment that would be a candidate of pixel for each model. So because we are using OpenGL, our shaders need to be described as GLSL. This is a language that we are going to describe the transformation and the fragment processing. Let's check. First, for the channel that we were linking in the last video, if you didn't watch it, you must too. And that's the layout function that links this input. The in means that it will be put it in here, and this is the main in. We have 3 types of operations between the data structure that we are using here. We have the in data structure, out data structure, and this is not it's a modifier. The in means that it will receive this from something else. The out means that it will be the return for each of the processing. We can have a factory as out too, because if you want to use a vertex position in fragment shader, you need to out from the vertex shader. And here we have a main because the shaders are simple and it needs to be compiled at runtime, it will be a simple program. For this one, this is extremely simple because we just passing the vertex position and attributing the coordinate system and the let's remember what is the correctly name. So this is going to be to the matrices tutorial, and then it's the output. This needs to be assigned to define the vertex position. It's a tricky, but it is really good way to define a multiple attribution. For this one, this is called swizzling. Here we have the output of the fragment shader. We just want to output a reddish color. This is a normalized vector for color, and nothing more than 1, nothing less than 0. 1 means that it's full color, 0 means that the pixel that we withdraw not going to receive a 0, that color to compose the entirety of the color. So if we have this, we're going to attribute to each individual pixel that will be formed with the red color. And that's it. This is a shader. Let's look into shader code. Oh, sorry. For our simple loader, we're going to use the vertex shader and the fragment shader. We have two shaders in the middle for the 4.0 OpenGL, but we won't going to use it. For loading a purely texted thing, we are going to use a readout text from a statically made file loader. This file loader are going to read the file, read each individual character, accumulate it, and return it. We can see it on some specific tutorial. And here we need the two fragments, the two shader code, the vertex shader and the fragment shader. This is the return of the shader. If it's true, it's going to be turned into true and everything is fine, but it's not used here. We are using this info log to get any log errors that are going to be handled by the shader itself, the shader compiler on runtime. Is a little print for explaining things, and we need a constant char pointer because it's a C-like language that we are using in not because it's a C-like language, it's because OpenGL handle because it's made on top of C language and not on any other kind of language. We have a binding for a lot of languages, but in this case we need to transform this to a simple array. And again, we created a pointer to describing the specific pointer where it's going to be on the GPU's memory, and then we compile it passing the vertex code, vertex shader code as a const sharp pointer, and then we compile it and check for errors. We check misheard here because this result going to handle the status of the error, the compiler status. And here we can have the info and log length that's going to fill the log info and print it out. The message by the shader compiler of the OpenGL. And here we have the same steps for the fragment shader. The same. Nothing changed in here. Instead of the shader code location on the GPU's memory. And then we link the program. We need to create a shader program that links the both vertex and fragment shader. We attach it to it and then link the program, and then we again get the status and a log error message from the OpenGL compiler. Then we delete the vertex and the fragment shader because we don't want to occupy the memory unnecessarily. And then we have linked the program, and now we can use it as in here because it's a simple use. We're going to change everything in here because it's not object oriented, and it's just for a simple loading and explanation about the fragment, the vertex and fragment shader. And here we use it. We call the OpenGL subroutines, and then we enable this channel because it's a state machine. We enable the channel, link the buffer. The buffer is linked to our triangle itself that is uploaded to the memory of the GPU, and then it's going to be attached to this location. And as simple as that, we are going to use this as a magic function in here because the OpenGL use this description to know how we can create the elements and the render pipeline come to the flow. And that's it. If you like the video, please hit the button like and subscribe to our channel for more motivational, and this is just for fun. Thanks for watching.